In this lesson, I'm going to go over the solution to exercise number 4. So here we have the complete code for the program that is used to determine the square root of a number. So we have two functions here. One of them is just a general function for calculating the average or mean of two numbers. Here we can see there's a docstring here, just a description of what this function does and what it returns. So it calculates the mean of two numbers, and it returns a plus b divided by 2. So the inputs or parameters that this function accepts are just two numbers. It averages those two numbers by adding them together and dividing by 2. Now here we have the main function that calculates the square root by guessing. And this function accepts three parameters. So the original number that we're trying to find the square root for, and then two whole numbers that are close to the square root of that number. So for example, if let's say the number is 27, right? We're trying to find the square root of 27. We know that it's going to have to be between 5 and 6. The square root of 25 is 5. The square root of 36 is 6. So in order to be able to use this function, you would have to know what two numbers you would have to know what those two numbers are, and you have to know that between those two numbers is where the square root is going to be. So this function finds the square root of a number by guessing over a range from low to high. Here we have a for loop. So this loop. So basically, this function, it's going to try 20 times to guess the square root. Okay. So the way this for loop works is, and it's going to repeat 20 times, is it's going to assign the average of low and high. Okay, so the two numbers here that were entered, low and high. And so it's going to assign the average to guess. Now if guess squared, so this is two asterisks in Python, means to the power of or to the exponent of. So if guess squared is equivalent to the number that is entered here, then the guess is just printed. Else if the square of the guess value is greater than the number, then the program is going to guess lower. So it's going to assign the guess value, the value that's currently stored in guess, it's going to assign it to the variable high. Okay? Now, if that's not the case, right, if instead guess squared is actually less than the number, then the value contained in the guess variable is going to be assigned to the variable low. Okay, and then in that case, what's going to happen is, again, the loop will repeat. And let's say it was this part over here, so if, let's say, guess squared is actually larger than the number, then high is now going to be the guess value. Okay, whatever the person guessed originally. Okay, and in the other case, if let's say the guess squared was less than the number, then low is now going to be the guess value. And so in a way, what this is doing is it's it's averaging two numbers over and over again until we get to the value for the square root of that original number that's inputted here. So it's like an approximation method of determining the square root. Okay, and so just going over this again, so we have the average function. The purpose of this function is to calculate the average of two numbers, a and b. This function accepts two parameters, a, the first number, and b, the second number, and it returns the average of a and b. Then we have our square root function. It accepts three parameters. So this function attempts to find the square root of a number by iteratively guessing over a range from low to high. So there are three parameters or arguments that this function accepts. Num, which is the number for which to find the square root, low, the lower bound of the guessing range, and high, the upper bound of the guessing range. So the method used here is, the function, the square root function, uses a loop that runs 20 times to make successive guesses at the square root of the number. In each iteration, it calculates a guess, which is the average of low and high, using the average function. It then checks if the square of guess is equal to the number. If it is, it prints the guess and exits the function. If the square of guess is greater than the number, it adjusts the high value to guess, making the range smaller and moving the guess lower. If the square of guess is less than the number, it adjusts the low value to guess, making the range smaller and moving the guess higher. After the loop completes, it prints the final guess. So here we have an example. So the square root of 25. So let's say we have two numbers here, 0 and 25. So this should print 5 exactly. Now this is an exact square root, right? So we technically don't really need to use this function to do this. Well, the square root of 2, right? Let's say we have our lower bound is 0, our upper bound is 2, should print a value close to 1.414. So these examples show how the square root function can be used to find the square roots of different numbers by specifying the range within which the function should search for the square root. So let's try using it. So I'm just going to do this in the shell. So I'm going to run, and I'm not calling the function right away. So I'm going to call it now. So square root, and so let's try 27. Low value I'm going to go with is 5. The high value I'm going to go with is 6. So I know it's between 5 and 6. Enter, and I get 5.196. Now if I were to go with, let's say I wanted, let's try 25 now. So 25, lower bound, let's go with, let's say 4, upper bound, let's say we go with 6, let's see what happens. We do get exactly 5, okay, as expected. Now the examples that are given here are 0 and 25, so that could also work. So let's try this, square root 25, lower bound is 0, upper bound 25, let's see. Okay, so this almost returns 5, or close to 5. So it's suggested here to use numbers that you know are very close. So lower bound and upper bound. So let's say we want to do, let's say 70, right? Square root of 70. So what are the closest perfect squares here. So 64, so 8, and then 81, which is 9, right? So let's try this out. So we get 8.366 and so on. So what's being returned here are floating point numbers. A floating point number has many decimals. It's a decimal value. Okay, so that brings us to the end of this lesson. Thank you for watching.